Welcome back, students. Video 19C. We've got to find out how do you find those critical t-values. So that's what this video is about. So finding critical t-values on StatCrunch. In a minute, we're going to hit the lights and I'll bring up StatCrunch. So we're going to look at two examples. These are the two we're going to look at. First, we'll say that we'd like to create a 95% confidence interval for a population mean. And we collected data. We had a sample size of 15. So we'll look at that first. You'll notice when we get to that one that critical t-value is going to be based on the fact that we want to be 95% confident as well as that sample size. Those are the two things that will be very important. In the second example, we'll switch up the confidence level. We'd like to create a 99% confidence interval. Again, still a population mean problem. This is why we need t. And we'll vary the sample size. This time we'll make the sample size 7. Keep in mind, why are we doing this? We're headed towards creating a confidence interval. In the previous video, I put up this formula for a confidence interval for a mean. We're going to take the sample mean, our best guess, and we're going to add and subtract the margin of error. The margin of error consists of that critical t-value times the sample standard deviation divided by the square root of n. So it requires this value of t. Everything else is going to come from our sample data that we collect, but we need to get that t-value. So we'll do this in StatCrunch. And one of the things I'm going to point out when we open this in StatCrunch is that if we incorrectly used the standard normal model, if we incorrectly made that a z, give the incorrect critical value. What would that z-score be? And you'll see that the t-value is correctly going to be bigger than that z-score. All right, so we're going to kill the lights, and I'll show you how to find these for our couple of examples. All right, so let's bring up StatCrunch. So the t calculator is from the stat menu under calculators. Just like before you went to the normal calculator, now we're going to go to the t calculator. Move this over here. And this is what this looks like. You'll notice that there's a box for degrees of freedom. In your first example there, it says that our sample size was 15. So I'll make some notes here. Since our sample size is 15, degrees of freedom is 1 minus that is going to be 14. So first thing I'll do, I'll update my degrees of freedom. And then the second thing that critical t-score is based on how confident you want to be. And for the first one, we want to be 95% confident. Think about what that means. The meaning of this isn't any different than it was for proportion problems. We want to find, down here now, these are going to be t-values, so that we get an area in the middle here that's 0.95. That'll leave an area for each tail of 0.025. So I'm going to sort of approximate, guess where I think this is going to be. We'll see how this works. This is sort of what I'm going for. The area in each of those tails is 0.025. I'm looking for that critical t-value right there. Whatever that is, this is the same value, just the negative. All right, so I've somehow got to tell StatCrunch, hey, I want that area there in the middle to be 0.95. There is a between function, but it doesn't really work very well for this. It won't allow you to say I want the area in the middle to be 0.95. So we're going to have to go with one of these tail areas. I'm going to pick the one up in the right tail. I'm going to say I'd like the area up in that right tail to be 0.025. So I want to find the probability that t is greater than what number when the area out in that right tail is 0.025. So let's make this x, which is really t, is greater than or equal to, and I want the area in that right tail to be 0.025. And when I hit compute, it's going to tell me, okay, that corresponds to a t-score of about 2.145. We'll traditionally tend to round t-scores to 3 decimal places. So I get a value of 2.145. It's fine. If you would have preferred to have found the area or this critical t-score that's over on the left, that's fine. I already know what that's going to be. That better be negative 2.145. So just to show you, you get the same thing. If I wanted the probability that x is less than 0.025, I'm going to get a critical t-score down here that's negative 2.145, same value. And for that confidence interval, we're adding and subtracting that margin of error, so that accounts for a positive and a negative t-score here that we're getting. And then just a reminder that you may want to jot down in your notes where we found this. This came from StatCrunch. We went under Stat Calculators T to get here. So you may write that down just in case you forget. Where did that calculator, where was that on StatCrunch? One more comment about this. Let's notice this. What if we had incorrectly used the standard normal model? What if we had used a z-score instead of a critical t-score here? Hopefully you remember, for a 95% confidence interval, the critical z-score was 1.96, right? And so you see that, we get a score there that's a lot smaller than this t-score that we actually got. So hence that could cause some issues there. So in your part B, you'll want to make a note that for a 95% confidence, z would equal 1.96. And so that would be the wrong value. Clearly, if we're working with means and not proportions, we want to make sure we don't do that, that we use this critical t value of 2.145. You notice you get a bigger value there. That's going to cause our intervals to be a bit wider since that t-score is larger than the z-score there. All right, that's the first one. Let's do one more. Let me clean this up and you can flip the page. In the second one, say we'd like to create a 99% confidence interval, and this time our sample size is 7. Let me start with the sample size. Since the sample size is 7, the degrees of freedom is only going to be 6 this time. And then we're switching up the confidence level as well. We want to be 99% confident. So now we're going to have the area in the middle here be 0.99. If the area in the middle is 0.99, each of these tails will have an area of 0.005. And I need to figure out, what's that critical t-score? What are these? So we're going to use the StatCrunch calculator. We've set our degrees of freedom. And now here it's sort of your choice how you use this. Again, I think I'm going to stick with the right tail. But I'm going to find out when t is greater than what number here do I get an area out in that right tail of 0.005. So let's make x greater than or equal to what number would give me an area out in that right tail of 0.005. And okay, I see here that corresponds to a t-score. I didn't quite know where that would be, and actually the picture changed because the degrees of freedom changed. But this corresponds to a critical t-score of 3.707 if I round to 3 places. Should have gotten the same thing if you did this one over here. Should have gotten a negative 3.707. So again, that's using that StatCrunch calculator. For part B, again, let's think about what if we made a mistake and we accidentally computed a critical z value. What would we have gotten? When you want to be 99% confident, if this had been a standard normal curve, when the area in the middle is 0.99, that corresponds to a z-score of 2.576. And so you'll notice that our t-value is fairly significantly bigger than that number. And so our t confidence intervals will, again, be a bit wider than they would have been had we used a critical z. So we want to make sure that we don't make that mistake. You're going to be using z with proportion problems. You're going to be using t when you're looking at mean problems. When we make that substitution, then when we don't know sigma and we use the sample standard deviation s, that causes more variation. We need to account for that by using the t distribution that's more spread out than the z distribution. All right, I think that's it for this video, just learning how to find those critical t-values. So we'll put those into action with some confidence intervals in some future videos. Thanks.